And when we talk about the HBr addition to an alkene, we have actually different products which are formed. In the previous case, when we talked about the regioselectivity of bromohydrine addition, the bromine added to the terminal carbon and OH added to the internal carbon. So, this is what we have seen. And in this particular case, when we are using no peroxide, the HBr addition, how it happens is the hydrogen actually adds to the terminal carbon, or we can call this as a less substituted carbon. So, the addition of hydrogen happens to the less substituted carbon and the bromine ion adds to the more branched or the more substituted carbon atom. So, this type of addition is called Markovnikov addition. When we use peroxides, we actually end up with the opposite of the product what we saw earlier. So, that means the bromine adds to the less substituted carbon and the hydrogen adds to the more substituted carbon, and these type of additions are called anti-Markovnikov addition. So, here also another example which is shown here. So, in this case also when there is no peroxide, hydrogen adds to the less substituted carbon, and when there is peroxide we end up with a product where hydrogen is added to the more substituted carbon. Now, the problem is, so far we know H plus adds to one of the carbon in the addition of HBr, because HBr actually breaks down like H plus and Br minus. So, in this case H plus is the electrophile which adds to this particular alkene to give our final product. So, if that is the case, why the presence of peroxides or no peroxides leads to different type of product? So, the reason can be explained based on what is the intermediate that is involved in the reaction.